Okay, so we're still really only in the introduction to balancing chemical equations, but I need to give you some more information to make this introduction complete. And that is that we need to point out that the physical states are going to oftentimes be given uh, in the reaction itself. For example, if I've got sodium mixed with water, I'm going to make sodium hydroxide and hydrogen gas, but this is solid sodium, this is liquid water, this is aqueous because it's dissolved in water. Too many arrows here, don't I? This is too many arrows. Okay, solid, liquid, dissolved in water, we're going to say aqueous, and a gas, which is bubbling off. Okay? So we need to appreciate that these are there, and oftentimes they're required, so watch out for them. And let's go a little further. Sometimes we're going to say some details about the reaction. For example, in this case, we're putting a little triangle there, right? So that's the uppercase Greek letter delta. And what we mean by that is it's carried out by heating, okay? And there's other symbols that we use from time to time, and that's what that means. This reaction, calcium carbonate, if we heat this, we can get calcium oxide, and we can get some gas that comes off of that carbon dioxide gas. All right. So this is not a simple issue here. We're gonna talk about ionic equations. Okay. I think it's really super valuable to you if you recognize polyatomic ions. So this is nitrate, and there is nitrate. And if you can see that you've got nitrate in there, then you sort of relax when you see NO3, and it just shows up again. This time you've got two of them, right, NO3. But it's important for you to appreciate that those oftentimes stay together. So molecular equations don't explicitly represent ionic species that are present in solution. So if this is calcium nitrate in solution, really the calcium is by itself, calcium 2 plus, aqueous, it's off by itself, and the nitrate is off by itself, okay? Now there's two of them here, right? So we might say 2 nitrate. But this is a molecular equation, sort of hides some of those details. Now, since we know what aqueous means, those of us who are used to looking at it don't have a problem with it, but sometimes it's really helpful to split it out. So let's talk about how those things really are. As I said in the previous slide, this solution really means that calcium's by itself because it's aqueous, right? So since it's aqueous, it's dissolved. Calcium is dissolved as an ion by itself, and so is nitrate is an ion that's dissolved by itself. Now, unlike these three ionic compounds, silver chloride does not dissolve in water to a significant extent. So let's go back and look at the equation. So if we have I want to go back and look at the molecular equation. The molecular equation, right? Aqueous means that the calcium is by itself and the chloride is by itself. Aqueous means that the silver is by itself and the nitrate is by itself. Calcium is aqueous, nitrate is aqueous, but that is not aqueous, so I cannot split that out because it's solid, right? And again, the only reason I could split those up was because it was aqueous. All right, so let's go look at the full equation again. In the complete ionic equation, this was aqueous, so we drew it by itself. This was aqueous, so we drew it by itself, and by itself, because they were all aqueous. But in the products, this is solid. You cannot split that out. And again, this is aqueous, so it was, and that's also split out because it's aqueous, okay? Now, that sort of begs a question. If this is the complete ionic equation, if we're starting out with calcium in the beginning as aqueous and calcium in the end as aqueous, there's no real difference there, right? So we might say, well, let's just get rid of that because it's not doing anything. It's just a spectator. And chloride. But chloride is doing something. Chloride is mixing with silver to become silver chloride, right? But nitrate's not doing anything. Look at that. Nitrate in the beginning, nitrate in the end. It's a spectator ion, okay? And so that brings us then to the final term. This is the complete ionic equation, and the final term is the net ionic equation. And in a net ionic equation, the two species that are present in identical form in both sides of the arrow, calcium and nitrate, are simply crossed off, right? They're spectator ions, and their presence is only there to maintain charge neutrality. They don't do anything at all in the process besides keep charge balanced. Okay? Elimination of the spectator ions results in the net ionic equation. Net ionic equation. Net ionic equation looks like this. I have silver, which is aqueous, chloride, which is aqueous. When they see each other, they say, hey, baby, let's precipitate. That is the net ionic equation.